So today I wanted to talk about testing and specifically the different types of testing approaches that I take when I'm developing software. So for a lot of my other content, and especially people that I work with and that I mentor in person, one of the things I focus on a lot is unit testing and really how you can write code that's very unit testable. And I found that over time, I am writing fewer and fewer unit tests, and I figured this video would be important because it's going to talk about why I'm kind of shifting my strategy, but why I still write code that is unit testable. So before I jump over to Visual Studio and start looking at some code, I just wanted to take this opportunity to discuss what I mean by unit tests and then the other types of tests I write. And I think this is important just because people might have different terminology and different expectations. So I don't want you to watch this video and then go, well, that's not what a unit test is by my definition. So I'm not here to debate or argue what the right definition of a unit test is. I'm just going to tell you mine, and then I'll talk about functional tests right after. So when I'm talking about unit tests, my ideal unit test is really something that's going to execute very fast. It's ideally looking at a single method. And the other things that are important are that it's not touching the environment. So that would mean like it's not going out to the internet, it's not writing files to disk or reading files from disk, it's not connecting to actual databases or anything like that. The idea when I talk about unit tests is that it's focused strictly on the logic inside of a method and everything else is isolated from that. So for me, that does mean mocking things out. So if you see my videos or if you're looking through code I write, I do use a lot of interfaces. Some people will some people will say, well, you shouldn't put interfaces around everything. I try not to put them on everything, but when it comes to writing unit testable code and the fact that I mock basically everything in my unit tests, I do end up leveraging interfaces for that. Now, do you have to use interfaces to mock things out? I'm not entirely sure all the frameworks that are out there for C# that allow you to do mocking, but basically from what I've seen using mock, M-O-Q, I believe I need to use interfaces and I follow this pattern and it really helps me write unit tests. So that's the unit testing part. Now, the functional testing part, it's sort of the opposite end of the spectrum. These could be longer running. It might be some people might say like it's an integration test, right? I'm touching multiple parts of the system connected together, and for me, these are leveraged not to execute and exercise code inside of a single method, but rather like some complex workflow. And I guess it's also worth distinguishing that with a unit test, I am asserting very specific things inside of the function, but with my functional tests or integration tests, however you'd like to call them, my assertions are a lot more simple. And that's because if I had a lot of assertions to try and, validate that every step along the way was perfect in my integration test, that would be extremely brittle to maintain. And in my opinion, my unit tests are the more brittle thing, where if I'm touching the inside of a function, my unit test is probably going to break. My functional tests probably won't unless I'm changing the overall behavior. So that's the terminology I'm going to be using when I get into this. And I think with that said, I can jump over to Visual Studio now. So on my screen, I have Visual Studio open. I'm in my Calarate ASP.NET application, and on my screen, I'm showing some tests that are result set tests. And these are something that I would classify as unit tests by my standard. And just to kind of explain what's going on, I'm using XUnit as the framework, so you can see that I have fact here on top of my method, which is the test method, and fact is just what XUnit uses to denote a test method. And the system under test in this case is my result set. And I basically, if you were to scroll through this, I just have a bunch of different scenarios that I'm going to be executing across my result set. Now, in this particular case, this result set object actually doesn't really have dependencies. So you'll notice, like if I go up, I'm right at the top here. I don't have any using statements for mock because I'm not mocking anything here. So this is actually like one of the most simple variations of unit tests. So just to kind of jump into this class to show you, um, the method, let me jump back, sorry. The method that we're going to be looking at is try get page. So let me jump right to that. And you'll see that I have this code written here, and we're not going to go through the details of this, but really my unit test is just exercising this code. So it's very specific to one method. And like I said, in this particular case, I actually don't even have dependencies that I'm wiring up and passing into this result set. I wanted to contrast that set of tests with another set of unit tests that I have, and this is for another class that I have called a quantity normalizer. So you'll notice here that I actually do have mock and a mock repository, so I am going to be using the MOQ mock framework and XUnit together, and this is just going to demonstrate, I'm just going to go through it briefly, like the fact that I have these interfaces that I'm mocking out. So you'll see in the constructor here, I'm using a mock repository to go create 3 dependencies, right? And then these 3 dependencies get passed into the system under test, so the quantity normalizer. And really, this is just a simple way of saying that the 3 dependencies that I have for this are not going to be real for the tests. I want to have full control over everything that's going to be executing inside of this quantity normalizer for my unit tests so that I can actually ensure that the logic I have inside of here is operating as expected. So just to quickly jump into this class, this quantity normalizer, this is a pretty nasty class that I have that's used for basically trying to deal with unstructured information. And this is something that I really wanted to be able to unit test because um, the complication with some of these other things, these dependencies, they would be a lot to go set up and ensure that they're all, functioning and sort of operating in a test environment. So for my case, I wanted to make sure the quantity normalizer worked. And I said, I don't care about the behavior of these other things. I have lots of tests on them in other spots. And one could argue for sure that I should have some functional tests that go across all of this together and test the integration of them for sure. But in my case, this is something that I wanted to basically have unit tests over so that I had a lot more specific control over what was being tested. So this is a little bit different than what we saw before. And in this case, I'm using a theory from XUnit. And for those that aren't familiar, a theory will basically allow me to have a set of data that's passed into the test. And you can see like this test actually has parameters on it, and it will pull that test data from this method. I'll look at that after and we'll go through that. And basically, it's just going to exercise sort of different inputs and expected outputs for this method. And the method that we're going to be looking at is try get quantity async. It's a pretty simple test as you can see, but that's because there's a bunch of other stuff that's actually in this method that generates the data. So I'm just going to jump into here to try get quantity async, right? So we're in this method now, and like what we're looking at in particular is not super important, but what I do want to call out is just how the dependencies are getting called here. So you can see that I'm accessing a cache. So this is a dependency that's passed in. We saw that as one of the mocked dependencies. The logger itself is also a dependency. And just to kind of prove it, if I scroll up a bit, you can see on the constructor, I have these 3 things passed in. They are interfaces. And we saw in the test setup that I have them passed in as mocks. And then if I scroll a little bit lower, you can see that I have the 3rd dependency accessed, right? So if I get them, I don't know if I can get them all on screen. I might have to zoom out a little. But yeah, there we go. So food client, I have the logger, and the scraping lookup cache. So what I was testing in my particular case is that I'm able to sort of flow over this logic. And if I jump back to the tests, you can see that I have a setup method on the scraping lookup cache and on the food client. And actually on the logger itself, I don't have anything set up. And I'm gonna call out like a pattern that I've actually this is something I don't recommend. It's just kind of interesting because it's on my screen right now. Um, this test very well at this point in the evolution of this project may actually be better set up as a functional test, and I just want to explain why. So every bit of code that I have is something that's going to evolve over time. Um, and in the beginning, when I had this, this is sort of part of a scraper tool that I have. And one of the reasons why this is probably set up as unit tests is because setting up the test infrastructure, like I was saying for these dependencies, like having an actual food client set up, um, the scraping cache is not so complicated, but this is actually backed by a database, and the logger is super simple. But these two things together are actually pretty complicated systems behind the scenes. At this point in the project's evolution, and I'm going to jump to a functional test after to show you, I actually do use Docker containers and stand up a bunch of dependencies. But at the point in time when I was writing this, I probably wasn't leveraging any of that. So this is mocked out. And just to jump back to the thing I wanted to call out here is when I'm mocking things, I almost never will put something like this, where it says it dot is any. And the reason for that, if I try to get this on the screen too, you'll see that my mock repository is set up with mock behavior strict. And what this is going to enforce is that any time we're calling a dependency from within the code that's being executed, it must be set up exactly the way we need it, because a mock behavior of loose will actually just kind of allow things to get called. And if it has a return value, it will just return the default. But I'm actually trying to prove that things are called exactly as I expect. When you start using things like it.isAny, you're kind of surrendering to the fact that like it could be anything. So I'm missing out on an opportunity to validate something here. And again, this is probably just because of at the time I wasn't able to set up good functional tests for this. And when I wanted to go make this a theory, which I'm just going to show you in a second to go expand this data, passing in the parameters the right way probably would have been just kind of messy. But you will see that on the food client here, this mock setup is actually not using it.isAny, so it is looking for a particular food ID. It's actually going to prove that we have the cancellation token and stuff like passed in here. So that's all great, but and like I said, the logger is not actually even set up because we're not expecting the logger to get called. It would mean that if something in the test, something in the system under test did end up calling the logger, this whole test would fail. And that's because the logger set up with mock behavior strict, and I'm verifying at the end as well. So that's actually, in my opinion, a way that I have a bit of protection here, that if that logic changes inside of this method here, try get quantity async, and say I started logging something, or we called some other method on the food client, I actually would expect this test to fail because it is a unit test. So by my definition, my unit tests are brittle because they're testing very specific logic. If I go up to here, just to expand this enumerable of the test data, this is a little bit nasty, but it's basically all the different scenarios that I'm trying to go run inside of that method we were just looking at. So every time we have one of these yield returns with a new object array, it's basically a new test scenario. So there's 2, 3, 4, 5, 6, 7. There's a whole bunch of them in here. And that way I can test different variations over the same body of code. But this is an example of, maybe not a great example, but of a unit test that I have that has mocked dependencies. So next we're going to go look at a functional test. All right, so on my screen I have a set of functional tests, and this is going to vary a ton from what we were just looking at with the unit tests. And that's because there's going to be no mocking, and we're actually standing up an entire ASP.NET application with dependencies, and it's going to get a little bit interesting here. So actually, I'm going to show you this one and then one more after that's a little bit more complicated for the setup. So this set of tests, and I want to talk about the evolution of my tests as well. And this set of tests is a copy paste pattern from something I had early on. And this kind of came out of not knowing how to properly set up Docker for some of my tests and get some dependencies stood up. So what we can see in the constructor of my test, this may not make sense to anyone who's not working in my code base, which is fine. But to briefly explain it, I'm basically setting up a local client that will go connect to my application server. But from looking at this, you won't be able to tell, but I'll explain that we're actually not even launching the application server. So you might ask yourself, okay, well, how are you testing it then? And the answer is that it's actually going against my live server and running tests against that, which is a little bit scary. But this is all because I did not know how to set up Docker originally for my dependencies. So I have a MySQL database, a MongoDB database. I'm going to have Redis. So I have a bunch of dependencies that I just didn't know how to stand up. So I started writing these tests so that I get some coverage. And in my opinion, some coverage was better than none. You can even see that I was documenting the tests with these traits that would mark them as slow, that it was live data, and that I would skip it on continuous integration because I couldn't even set it up in continuous integration properly. But what I would do before committing is I would go run these locally, and if things look good, it was at least some confidence that I could go check in my code. So, of course, these aren't great, but just to kind of show you, I want to be able to test a post method with an empty body. And if I hit the API, and if you see up here, the base route is actually here, recipes list enhanced. If I hit that with a post, I do expect that it fails with a particular error code. And these tests are all kind of like that. This one at the bottom is sort of the happy path. So if we were to go hit this route with these parameters, I actually expect it to succeed, and then we get some response that comes back. So the reason I wrote these tests, like I said, is that I wanted some confidence that I didn't blow up everything. And the nice part about these tests, even though it's against the live server, which I do not recommend anyone do, the nice thing about this is that it would basically test a particular path from the routes, right? So hitting a web API all the way down through the database and then back up, which meant if I was hitting, multiple microservices along the way, if I was doing multiple database queries, hitting caches, things like that, all of that stuff is getting exercised as part of this test. And I use the word exercised on purpose because that is different than asserted. So in this case, this test would exercise a lot of code, which meant there was a lot of code that was touched, and so a wide area of coverage. But in terms of what's actually asserted, you can see that I only have like two things as part of this test. This assert up here is just to prove that we could actually log in, but this assertion is very simple. It's not actually checking any of the logic inside. So this is sort of one of my early functional tests. I kind of explain why I have it. And I'm going to go pull up another one that actually has a better pattern where I have the dependencies actually stood up with Docker. All right, on my screen now is a similar pattern to what we saw, except this one is not going to exercise code that's on the live running server. Instead, I am using these fixtures that you can see here, and one of them is for MySQL. And you can see that's kind of passed into the constructor here. And then we saw a similar pattern, like this builder pattern in the other test, but this time we're going to be setting up a local server and actually using the MySQL container. So this test will go launch Docker, and it will go launch Docker for MySQL, and it will launch Docker to actually go run my web API locally. And that web API that runs locally will connect to that local Docker. So two containers talking to each other. Now, the huge benefit of this is that I'm not actually hitting my live server. Obviously, that's not a great pattern that I want to be following, but this is sort of the evolution that I've arrived at where I'm no longer required to be writing unit tests over very specific things. And if we kind of scroll through it's very similar to the other tests we just saw, right? It's almost the exact same pattern. Like, we're testing if a method's allowed or not. If I scroll to the very bottom, there's sort of like this happy path variation. So all the same reasons for writing tests like this that apply to the last scenario we looked at. It's just that I don't have to run them against the live server. So every test that I have that looks like the last set that does go against the live server, I am going to be going back and refactoring. So it will have these fixtures and a setup just like this one. So now that we've looked at a bunch of code, including unit tests that basically had no dependencies to mock out, unit tests with dependencies to mock out, some functional tests against a live server that I don't recommend anyone does, and functional tests that actually run against some Docker containers with my dependencies stood up, I just wanted to talk about sort of the different flavors of these tests that I have, why I have them, the evolution of that, and kind of tie it all together with why I'm for the most part, moving away from unit tests. So this application that I have is growing significantly over time, and a lot of it's in flux. And what I mean by that is that as I'm creating routes and APIs, the other members of the team that I'm working with, we are finding that sometimes a particular route we might have to blow away where we need something else that's new. So we're always iterating and changing things. And the reality with the unit test sort of setup that I was describing is that those are brittle. So I could go write unit tests on all of that stuff, but because it's changing so much, a lot of what I need to be exercising is going to require that I would rewrite those unit tests. So what I've been finding is that when I write these functional tests, again, trying not to hit the live server anymore, but standing up the dependencies with Docker, I'm able to get a way broader coverage, better bang for the buck, so to speak. When I go run these tests, I know that it's going through my app stack. I can test basic functionality that someone on the front end calling my API, they might expect that sort of result to come back. And just overall, it's giving me, like I said, better coverage. So does that mean that I've stopped writing unit tests entirely? No. I still write them. I still write my code so that it can be unit tested. And because I have these patterns that I've adopted over time that allow me to write unit tests easily, so things like passing in all of my dependencies as interfaces that I could mock. If I ever found that part of my system was solidifying more and I wanted to have more specific coverage over particular methods, I'm set up to go unit test those very easily. That would mean that the functional test could remain in place, give me some high level confidence that, the whole world didn't fall apart because I accidentally changed a SQL query somewhere. So I'd have pretty good confidence that things are mostly okay. But for more complex areas and areas that are more solidified, I can go back, easily add unit tests, and get that much more confidence that those really important areas are covered and the logic is sort of it's well understood and well asserted on. So I think that's mostly it for what I wanted to cover. In the next video that I put up, I'm going to walk through in particular my cache test that I wanted to unit test because I needed to have a lot more confidence in the behavior, and I think that'll be interesting to contrast with the follow-up to that, which is some of the functional tests, and I'll step through some of the stack of that so we can look and analyze to see like why that's valuable to functional tests. So hopefully this was useful. I just wanted to compare and contrast the different types of tests I have, why I do them that way, and sort of how that's evolved over time. as my application has grown. So thanks for watching, and we'll see you next time.